Welcome you all again in my YouTube channel. Today we will discuss the topic of gravitation, that is part 2. In my last video we have discussed a lot of things from the gravitation, the concept of gravitation, what is the universal law of gravitation. After that, G, the value of capital G, what is the meaning of capital G, then acceleration due to gravity, etc. So here in this part 2 video we will discuss the rest of the portions. Okay, so let's start our topic. So the first thing that we will discuss from acceleration due to gravity. Why I say this is acceleration? Suppose I am throwing any object downwards. So in that case the object will come down. Why? Just because of the gravity that we know. And while falling down, that time the velocity of the object will be changed. Why the velocity will be changed? Now due to the same reason, due to the gravitational pull of the earth. So what we know, the change in velocity is to be called acceleration. So here the object is facing change in velocity due to gravitational pull, and that is why we say this is acceleration due to gravity. The force is called acceleration due to gravity. Now the point is that, is the value of small g constant? No, the value of small g is not constant. It may vary at different places. Why? Now because if we see the relation between small g and capital G, we understand that it is small g equal to capital G into capital M divided by r square. Now what is r? R means radius of the earth, or you can say this is the distance between earth and any object. Fine. So r is not a constant term, but when we know कि G is a constant, means capital G is the constant, because capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So this is universal gravitational constant. Then capital M denotes the mass of the earth. The value of capital M, this is also constant, like 6 into 10 to the power 24 kg. So capital G, capital M, these two are constant, but R is not the constant. Fine. So here what is the relation we are getting between small g and R? They are inversely related. So acceleration due to gravity is inversely proportional to the square value of radius of the earth. So what is the meaning of inversely proportional? If the value of r will be maximum, so in that case value of small g will be minimum. If the value of capital R will be minimum, so in that case value of capital G maximum, right? So if I imagine कि suppose I am standing at the center of the earth, so at that case what is the value of G? What should be the value of G? Right? So if I am standing the center of the earth, so there the value of R, definitely this is minimum, so definitely I should get the value of G maximum. And I am going to the north pole and south pole direction, in that case the G will be minimum, because if you are going to north pole and south pole, then value of R is increasing, and at the maximum value for R we get the minimum value of G. This is the meaning of inversely proportional. Fine. Achha. After that the next topic comes, that is free fall. What do you mean by free fall? Free means there will be no obstruction. Any object when moved down freely without any obstruction, that is to be called free fall. That incident is called free fall, and the object is to be called free falling body. Acha, suppose you are standing on your roof and from there you are throwing a ball, and then you are telling me ki ma'am, now is it the free fall? Is the object is free falling object? No, this condition is not free fall. Why? Because when you are throwing the ball, that time the ball has to cross the obstruction created by the air molecules or by the atmosphere. Fine. So in that case, how it will be free? At each and every moment it has to cross the obstruction caused by the air molecules. This is not a free fall. But if I am be able to do the same experiment in the universe or at the vacuum place, vacuum means there will not be any air molecules, nothing is present, completely vacuum. At that position, if I do my experiment again, then it will be said free fall, because there is no obstruction. So without any obstruction, directly the ball will come down. That is free fall. Now we have to understand some rules regarding the free fall. The first rule is that if you are able to do the experiment in a vacuum, so in that case, during the free fall, heavier object, lighter object, both the object will reach to the ground at the same time, because there is no obstruction. That is why. But if I do the same experiment from my roof, so there what the incident I can see, now the heavier object will reach to the ground faster, while the feather like lighter weight object has to cross the the obstruction of air molecules, and it will take longer time. So it will take much more time to reach the ground. So here in that case, or in the real cases, we are not getting this rule कि lighter object, heavier object, both the object will reach to the ground at the same time. This rule will not be applicable if I do the experiment on my roof. Fine? Acha. Next rule is that as time will be increasing of free fall, more and more distance or height will be covered by the object. Fine? So during the free fall, we have to check the timing. So as timing will be increased, the object will cover more distance with respect to time. Next, just before of touching the ground, then one point will come when the velocity of the object will be 0. Just after that, the object will touch the ground. The object will touch the ground. Fine? And then the whole kinetic energy suddenly will convert to its potential energy, because during the free fall, whatever the kinetic energy was stored in the body of the object, that suddenly will be converted to the potential energy of the same object. Okay? Achha. Next is that the equation of motion during due to acceleration due to gravity. So we can say V equal to U plus gt. This is the first equation of motion. Second is that S equal to ut plus half gt square. Then 2gs equal to v square minus u square. And now you can say ki ma'am, this formula to we have learned in the chapter of motion. Yes, definitely that we have learned it in the chapter of motion, right? But there, instead of small g, we have written a, like v equal to u plus at. What is the meaning of a? A means acceleration or only acceleration, you can say. But here when I am telling about small g, that means I am denoting acceleration due to gravity, and that is why I said this is the equation of motion just due to acceleration due to gravity. Due to the gravitation, due to the gravitational motion, some equations that we have already learned, that will be rewritten. So after doing the rewrite, so we get the formula v equal to u plus gt, then 2gs equal to v square minus u square, then s equal to ut plus half gt square, etc. So what we will do here, do we have to make the derivation? No. We do not need to do any kind of derivation of this equation of motion here. In the chapter of gravitation, we do not require the derivation. Just we have to learn the formula, then we will apply it for solving some numerical problems. We will put the formula in the case of numerical problems, and then we find the result. Okay, so in my second video I have discussed with you the topic of acceleration due to gravity, then what should be the value of g, means small g, then free falling body, the rules regarding the free falling body. After that, equation of motion, I repeat, due to the gravitation. And the last thing, that is a short question, ki what is the value of small g? If this question you will get, so their answer will be 9.8 meter per second square. And then you can ask him, ma'am, as you have said this is not a constant value, then how can you say 9.8? Definitely the value of g is not constant, but still for making our calculation easier, we have to take a standard or convenient value. So for solving our numerical questions, we need a convenient or standard value, and that we take 9.8 meter per second square, or sometimes directly in round figure we write 10 meter per second square. Now how we can do that? We have to do the calculation. Small g equal to capital G into capital M divided by r square. So the value of capital G, that is universal constant, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then into capital M stands for the mass of the earth, that is 6 into 10 to the power 24 kg. Then divided by value of r. R means the radius of the earth. You can write 6.4 into 10 to the power 6 meter, then whole square. Okay, so after putting the value of G, M and R, then approximately we get 9.8 meter per second square. So that is why I told you we can use that for solving our numerical problems. But that doesn't mean the value of G is constant. No, this is not actually constant. Always it will vary if we change the places. Fine. So in my next video, I will discuss with you some important question answer regarding gravitation, because part 1 and part 2 video completed, and in the third video the important question answer I will discuss. Then the gravitation portion will be completed. Okay, chalo. Bye everyone.